Okay, so now in this video we want to talk about permutations when all the objects are not distinct. So basically what we had so far was basically we were talking about the permutation of objects that were distinct. And what I mean by that is that, for example, we were talking about the permutation of objects that are distinct. What that means is that, for example, in the basically using the example that we had before, and the example that we use in order to derive the formula. So we used the letters of the word. We used the letters of the word rose. We used the letters of the word rose in order to make, for example, four-letter words. Four-letter words. So basically what we did was that we took all of these letters and then we rearranged them, and we basically what we got was something like, for example, permutation 4, which is equal to 4 factorial over 0 factorial, which is equal to 4 factorial, which is equal to 4 times 3 times 2 times 1, which is equal to 24. So what that means is that if you take the letters of this word rose and keep rearranging them, you will get 24 different words with or without meaning. Meaning that if you take the letters of the word rose and keep rearranging them in every possible way, you will have 24 different words with or without meaning. Assuming that you don't repeat anything, that you don't repeat the letters. Okay, so that's basically what we did before. And what's important here is that basically the word rose, and we use basically the letters of the word rose. You see, the word rose has basically an R, it has an O, it has an S, and it has an E, right? So in this word, no letters have been repeated, meaning that if I take these letters as objects, these objects are non-repeating. These objects, meaning R, O, S, and E, are non-repeating. Now suppose that, for example, you have a word like root. Suppose that you have a word like root, and you want to use the letters of this word in order to basically, in order to make four-letter words, meaning that you want to use the letters in the word root in order to create four-letter words by rearranging the letters in every way possible. But not repeating the letters, right? Now the problem with this word is that if I think of this word as, for example, if I think of the letters of this word as objects, I will have an R, I will have an O, I will have another O, and I will have a T, right? And if I think of these as objects, then of course these objects are not non-repeating. And so what that means is that you will get into a problem, meaning that, for example, suppose that for example you start with an R here, so that the first you want to make four-letter words. So you have the first letter here, the second letter here, the third letter here, and the fourth letter here. So the first letter, you can choose either of these letters over here. So you could choose an R, you could choose an O, you could choose an O, you could choose a T, right? Now the problem is that you have already repeated. The problem here is that you have already repeated your O over here. And now suppose that, for example, you have your R over here, and then basically after R you have three choices there. You could choose an O, you could choose an O over here, and you could choose a T over here. And again basically you have for example, let's say that you've chosen an R and an O, and then you could choose an O again, or a T here, and over here you could choose a T, over here you could choose an O. And then again the same thing happens. Again, over here you can choose either for example an O or a T. You could choose either an O or a T, and then over here you could choose a T, and over here you could choose, for example, an O. And over here what happens is that you could choose R and T, so you could go for O and O. And since over here you have chosen RTO, again you will get an O over here, you will get an O over here. So you see that you're getting into trouble, and what happens is that basically over here you have ROOT, over here you have ROTO, over here you would have ROTO, over here you would have ROOT, over here you would have ROTO, over here you would have ROTO, and over here you would have RTOO, you would have RTOO, and over here you would have RTOO. So you can see that, for example, this word ROOT has been repeated twice. This has been repeated twice, and this has been repeated twice. Okay, so that's the kind of problem that you would get into. So now we need to find a way to basically solve this problem, and let's see how we can do that. Okay, so now you understand the kind of problem you would get into if basically if you have repeating, for example, if you have repeating objects in your objects, meaning that suppose you have, for example, these objects over here, and if the objects are repeating, now it could be, of course, it could be anything, but as long as your objects are repeating, you would get into this sort of problem. Okay, so now let's see how we can solve this problem. So suppose that we have to find the number of ways. So suppose that we have to find the number of ways of rearranging the letters of the word root, of rearranging the letters of the word root. In this case, the letters of the word are not all different. Of course they are not. And there are two O's which are of the same type or of the same kind. So they are the same kind of letters here. Now, temporarily, let us treat the two O's as different letters. Let's say, for example, O1 and, for example, O2. The number of permutations of 4 different letters, in this case taken all at a time, is 4 factorial. So then the number of permutations of 4 different letters taken 4 at a time would would be 4 permutation 4, which is the same thing as basically 4 factorial over 4 minus 4 factorial, which is the same thing as 4 factorial over 0 factorial, which is the same thing as 4 factorial, which is well, let's call it 4 factorial for now. Now consider one of these permutations. One of these permutations, say for example R01, for example O2T. Corresponding to this permutation, corresponding to this permutation, we have 2 factorial permutations. We have 2 factorial permutations. And I'm going to tell you why that's 2 factorial. Basically, namely R01 O2T and R02 O1T, right? So, which will be exactly the same permutation if O1 and O2 are not treated as different. Which will be exactly the same permutation if O1 and O2 are not treated as different. That is, if O1 and O2 are the same O's at both places. So that means that basically so what that means is that you need to basically take these permutations out, because as you can see here, I have treated O1 and O2 as different letters, and then relative to that I have come up with, for example, R01 O2T and R02 O1T, right? But if I don't treat them as different letters, and if I treat them as just simply O's, this would be ROOT and ROOT, which would be exactly the same words, and I don't want to have these words repeated in my results. I want to have basically I want to have distinct results when I calculate the permutations of basically the permutations of the rearrangement of the letters of the word root, right? So what I'm going to do is that I'm going to take this. I'm going to have to take this 2 factorial permutation out, and it is 2 factorial because as you can see over here, suppose that I have R, for example, R01, for example, O2T, right? I have this basically this word over here. Now temporarily I have treated O1 and O2 as different letters. Now supposing that O1 and O2 are different letters, let's calculate the the permutations of the two letters O1 and O2 and O2 only, meaning that the number of letters is 2, meaning that n is equal to 2, and then of course I'm taking both at a time, so if my r is equal to 2, so then that means that basically I'm calculating 2 permutation 2, which is equal to basically 2 factorial over 0 over 2 minus 2 factorial, which is equal to 2 factorial. That's basically why here we said that that's 2 factorial there is 2 factorial permutations relative to these two repeating letters. So now basically that all the permutations related to this word, treating the two O's differently was 4 factorial, and the permutations of this, the different permutations of the O's were 2 factorial, and of course you have to take that out. Now in order to take that out, you need to divide, and you need to understand why you divide here. So in order to understand why you divide here, so basically what you need to do is that you need to take your 4 factorial and divide it by 2 factorial in order to take the repeating words out, meaning that you would get basically, for example, 2 factorial times 3 times 4 over basically 2 factorial, and then these two will be cancelled out. You'll be left with 12, right? Now, in order to understand why you're basically dividing, it's the best way to explain this is that suppose that, for example, you have for example, I don't know, 24 words. Suppose that you have 24 words here. So you have word 1, you have word 2, you have word 3, you have word 4, you have word 5, you have word 6, you have word 7, you have word 8, you have word 9, you have word 10, you have word 11, you have word 12, you have word 13, you have word 14, you have word 15, you have word 16. So you have word 17, you have word 18, you have word 19, you have word 20, you have word 21, you have word 22, you have word 23, and you have word 24. You have all of these words, and if I ask you how many words are there in total, and I'm asking basically simple questions, don't take the question as a stupid question or anything, because what we are learning here is actually we are learning how to count, right? So it's a very simple concept, but we need to learn how to count. So the questions basically the examples here are actually very simple examples. But then once you learn these basically the concepts here, then you can use the concepts in many advanced types of situations, and you can use them in in very powerful ways, really. So if I ask you how many words are there in total, how many words are there in total, you would tell me that there are 24 words in total there. Now, assuming that, for example, word 1 and word 2, take them, if I were to take them as one word, if I were to treat them as one word, word 3 and word 4, treat them as one word, word 5 and word 6, treat them as one word, 7 and 8, treat them as one word, and so on and so forth. And do the same thing over here. Treat these as one word, these as one word, and so on and so forth. Now, treating every 2 words as one word, how many words are there now? How many words are there now? So to answer this question, you would just simply take the whole number of, basically the total number of words, which is 24, and divide it by 2. And then you would tell me that there are 12 words now. There are 12 words there now. Now, for example, if I asked you, for example, now, suppose that I take each 3 words and treat them as one word, right? And so on and so forth. Now, treating every 3 words as one word, how many words are there now? So then you would again take the total number of words, which is 24, divided by 3, and then you would tell me that there are 8 words. There are 8 words there now, right? And so on and so forth. And so what I've done over here is that basically in total there are 4 factorial permutations there. Now, what I have done is that basically I have treated every 2 factorial permutation as just one single permutation, right? I have treated every 2 factorial permutation as one single permutation. So then now let me write this down. Now in this situation there are basically in this situation we have 4 factorial permutations in total. Now treating every 2 factorial permutations as just one permutation, how many permutations are there now? So since we had basically 4 factorial permutations in total, and we are basically treating every every 2 factorial permutations as just one permutation, and you just simply divide by 2 factorial, and that would be basically the total number of permutations that you have over there, right? And that's basically why you divide. Now to understand this situation, this situation more clearly, we need to write down all the permutations of this word root, right? So for example, let's say that you have the permutations when O1 and O2 are different. Over here I can write the permutations when O1 and O2 are different, are basically treated as different letters, and then you can also have the permutations when O1 and O2 are the same O. So now let's see what we have here. So we have basically the letters that we have are basically so let's say that you have 4 letters, and you want to calculate the permutation of 4 letters taken 4 at a time. That would be 4 factorial, which is equal to 4 times 3 times 2 times 1, which is equal to 24 permutations. And then you have basically, let me see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 18, 20, 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 24. Okay. So now what we have here, we have 24 different words using these 4 letters. So let's list these words. So you have the letters R, O, O, T. So let's start with, for example, R. Let's start with R, and then R, after R you can choose, for example, let's call this O1 and O2, for example. Then you can have, relative to this choice, you have O1, O2 and T. O1, O2 and T. Relative to this choice you have O2 and T. O2 and T. Relative to this choice you have RO2, so you have O1 and T. You have O1 and T. Relative to this choice you would have O1 and O2. Now relative to this choice you would have RO1, O2 and T here. You would have RO1, T and O2. RO1, O2 and T here. And over here you would have RO2, T, O1. And over here you have RT, O1, O2. RT, O2, O1. So you have basically all of these words here as RO1, O2, T. RO1, O2, O1, O2, T. RO1, T, O2. RO1, T, O2. RO2, O1, T. RO2, O1, T. RO2, RO2, T, O1. RO2, T, O1. you have over here RT0102, and over here you have RT0201, right? So you have basically 6 of your wards here, and then you have another 4 of them, which makes them 24. So so now what I need to do is basically so now I can rearrange these. For example, I can write them as R0102T, for example, R0102T, and so this is taken care of, and R0201T, R0201T, right? So this is basically these are the permutations when O1 and O2 are treated as different letters, right? And then you have, for example, R01TO2, R02TO1. So you can write these two together. For example, R01TO2, and you have R02TO1, R02TO1. You can put them together as well. And then you have basically RT0102, RT0102, and RT0201, RT0201. So this is for R. Now again we have a couple more of these to do, right? So this was for R, and I'm going to basically write them all over here if it's possible. So suppose that now you have, for example, okay, so now let's do the next one. Now this time what I'm going to do is that I'm going to start this, basically the first time I started with the R. The second time I'm going to start with T, for example. So that means that when you start with T, then after T you have 3 choices: R, O1, and O2. You have basically R, O1, and O2, right? And once and then after you make each of those choices, let me see. Okay, so now since this thing can take a whole a long time to figure out. I mean, you have to basically write in the same way that I wrote these results over here. You have to start with O1 again, and then you have all of these basically things over here again. You have to start with O2, and then you have to start with T, and then you would have 3 times 6, another 18 results over here, and 18 plus 6 is equal to 24. So what I have done is that I have basically already written everything myself on these boards, and what I will do is that I will just simply copy them here to I thought you might not want to basically see me go through this whole process, so I just did all of that by myself. And so you have TR0102. So you have basically TR0102. You have TR0102, you have TR0201, you have TO1RO2, TO1RO2, TO2RO1, TO2RO1, you have TO1O2R, TO1O2R, you have TO2O1R, okay, and then you have O1O2RT, you have O1O2RT, you have O2O1RT, and of course you do understand that, for example, these two results come from two different processes, meaning that, for example, to get this result you have to start with O1 and do the whole thing related to O1. To get this result you have to start with O2 and do the whole process related to O2, and then basically you have to keep them and then put them together like that. And the same applies to, well, almost every other one of these that I have written over here. So RT, O1R, O2T, O1R, O2T, O2R, O1T, O2R, O1T, and then O1RTO2, and then O1RTO2, then you have O2RTO1, and then O1O2TR, you have O1O2TR, and then you have O2O1TR, and then you have O1TO2R2, O1TO2R2, you have O1TO2R, O1TO2R, and then you have O2TO1R, T and R, and then you have O1TRO2. You have O1TRO2, and you have O2TRO1. So in total you have basically all of these results, meaning that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 times 2 is equal to 24. 24 basically permutations. Now I have 24 permutations when O1 and O2 are treated as different letters. Now if I treat basically all of these as basically, if I treat the O1 and O2 as the same letter O, what I will get is that, for example, for these two, I will simply get ROOT. ROOT in both cases. ROOT, ROOT. For these two, I will simply get, for example, ROTO. ROTO. For these two, I will simply get RTOO. RTOO. For these two, I will simply get TROO. For these two, I will simply get basically TORO. TORO. For these two, I will simply get TOOR. TOOR. For these two, you will simply get OORT. For these two, you will simply get basically OROT. OROT. For these two, you will simply get ORTO. ORTO. And for these two, you will get basically OOTR. And for these two, you will get OTOR. OTOR. And for these two, you will get OTRO. OTRO. Right? So then basically in total over here I have 24 permutations. Over here I have 12 permutations, which is basically, this is 4 factorial. This is 4 factorial divided by 2 factorial. Now what I have done here is that in total I have 4 factorial permutations here, which is equal to the same thing as 4 times 3 times 2 times 1, which is equal to 24. That is equal to 24. Now since I have taken each 2 factorial permutations as just simply one permutation, so then I have divided 4 factorial, the total number of permutations, by 2 factorial, and so as a result what I've gotten is basically 24 divided by 2, which is equal to 12. That's basically what you do when your objects are repeated. When your objects are repeated. So that's basically, for example, this example here, and I just wanted to show you that what happens when objects are repeated and what you do in that case, and why basically you have to divide. Of course, dividing makes sense. I mean, in simple cases you would most probably simply come up with the division basically solution. But then when you probably don't understand the concept properly, then you might actually not come up with the solution of division. But for example, if I told you that, for example, I have all of these words over here, words 1, word 2, word 3, word 4, for example, word 5, and word 6 here, and so there are 6 words in total here. Now if I told you that I take each 3 word as one word, taking every 3 word as one word, then you would say, then in order to tell me that, in order to say how many words are there now, I would just simply take the 6 words and divide it by 3, which would give me 2 words here, 1 and 2, right? So I have done the same thing here. I have 20 words here. I have 24 words here. Now taking each 2 word, or taking each 2 factorial word as one word, then you would just simply take your 24 and divide it by 2 factorial. That's all there is to it. Very simple. But of course very powerful, really powerful. You will see what sort of problems you can solve with these simple methods of counting. It's just simply only counting 1, 2, 3, 4, 5, and so on and so forth. But with these methods of counting, you can do wonders. We will see about them as we go along. So now let's do another example here, and let's find the number of ways of rearranging the letters of the word institute. Let's find out the number of ways of rearranging the letters of the word of rearranging the letters of the word institute. So the word institute has basically you have one and two eyes in here. You have two eyes in here. You have one N, you have one S, you have 1, 2, and 3 T's. You have 3 T's, and that's it. I mean that the repeated letters are these two letters. And in total you have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. And N is equal to, and you have 9 letters in total. Okay. So what you need to do, what we want to do basically, we want to find out again the number of ways of rearranging the letters of the word institute, meaning that you want to find the permutation of basically 1, 2, 3, 4, 5, 6, 7, 8, 9 objects, the permutation of 9 objects taken all at a time. Keeping in mind that basically one of the objects has been repeated twice, or well, it's a tricky thing. One of the objects, I cannot say that it's been repeated twice, because if I say that I has been repeated twice, that means that I have 3 eyes. To make it more clear, I would say that one of the objects is present 2 times in total, 2 times, and another one basically 3 times. Okay, so I don't really know how people, how you should talk about this kind of thing, meaning that, for example, I would be confused if I said that, for example, if you say that, for example, if there is basically 3 T's in here. There is 3 T's in here. Now there are 3 T's in here. I cannot say that T has been repeated 3 times. Then I wouldn't know what they meant by that. So I'm just going to write it clearly like this, at least for now. So now, in order to do this, so in this case there are 9 letters. There are 9 letters here, in which I appears twice. So I appears twice, that's a good way of talking about it. And T appears 3 times. So I appears twice, t appears 3 times. Now temporarily, let us treat these letters differently as different letters and name them as I1, I2, T1, T1, and T1, T2, and T3. So what we can do, we can say that I can say that temporarily we can treat these the I's and the I's and the T's as different letters and write them as basically over here I have 2 I's, so I1 and I2 and T1 and T1, T2 and T3. So the number of permutations, this is important, you need to pay attention to this. Okay, so now, so we said that temporarily we could treat the I's and the T's as different letters and write them as, for example, I1, I2, T1, T2, and T3. So the number of, so now if that was the case, if that's the case, then you have basically the word that you have here is basically the word is institute. The word is institute, and this word has all of these. Then if I treat these I's and these T's as different letters, then you have basically 9 different letters, 9 different letters in this word. You have 9 different letters, and you want to basically rearrange them. You want to rearrange them in every way possible. And the question that I want to answer is how many such arrangements are there? How many such different arrangements of these letters are there? So we have already solved that problem, and we basically came up with the concept of permutation. Before, and we said that basically n permutation r is equal to n factorial over n minus r factorial, and this is assuming that basically no repeat, we are not repeating anything, meaning that here repetition is not allowed. If repetition is allowed, then basically the number of arrangements would be n raised to the power r, for example, something like that, or exactly that. But, well, of course, that's not what we are concerned about here. We are not repeating anything, so it's just simply n permutation r. Now over here I have my n is equal to 9. My n is equal to 9 and my r is equal to 9 as well, because I'm rearranging these letters, meaning that I'm making basically 9 letter words using these 9 letters. So my r is equal to 9, my n is equal to 9. And so if I calculate this permutation, that would give me basically 9 permutation. 9 permutation 9 is the same thing as basically 9 factorial over 9 minus 9 factorial, which is the same thing as 9 factorial, right? Now, but the problem here is that, again, we would get into the problem of the basically we here again we get into the trouble that we got ourselves into, which was related to the word root. In the word root we have basically two O's that were repeated letters, and then those two letters gave us all of those repeating results in the results. And basically we had basically 24 permutations, and then once we calculated everything, the whole thing was reduced to only 12 permutations. So we have to do the same thing over here. So now what I need to do is that basically take all of these permutations, which is 9 factorial, and then take out all of these letters that have been repeated, meaning that, for example, here I appears twice. I appears twice, and also T appears thrice. T basically appears thrice. So this is 2 times and this is 3 times. So that means that the different permutations of I have to take it out. So how did I take out the different permutations of the two basically O's in the word root? I calculated basically the permutation of the word root, treating basically these O's as different O's, meaning O1 for example and O2, and then that was permutation 4, which was equal to 4 factorial. And then since the permutation of these two letters was 2 factorial, then I took this 4 factorial and divided that by 2 factorial, and this was the actual basically the actual number of permutations of these 4 letters, considering the fact that basically the two O's appear twice, basically, or the or basically O appears twice. So I'm going to have to do the same thing over here. So I'm going to right now basically in this example, what we have is that basically the permutation of all of these letters, treating them as different letters, is 9 factorial. But then I have to take my 9 factorial and divide it by basically the permutation of basically these I's that, for example, appear twice. So that would be basically just simply 2 factorial. Because this is 2 letters. These are 2 letters. And if you want to calculate the permutation of 2 letters taken 2 at a time, taken all at a time, or meaning that you have basically you have 2 objects basically taken all at a time, so that would be basically 2 permutation 2, which is 2 factorial, right? So that the 2 factorial I have written over here. Again, I have this T that appears thrice. That means that I have 3 objects. That means that I have 3 objects, and I need to take out the permutations related to this T as well. So the permutation of this T would be 3 objects taken all at a time. Taken all at a time, which is the same thing as basically 3 factorial over 3 minus 3 factorial, which is the same thing as 3 factorial. So I have to multiply by 3 factorial as well. So now what I can basically what I can say is that basically the total number of permutations, the total number of permutations would be 9 factorial by 2 factorial times 3 factorial, which is the same thing as, well, you could say, for example, 3 factorial times 4 times 5 times 6 times 7 times 8 times 9 over 2 times 3 factorial, and then you can simplify these, and that's 72 times 56 times 10 times 10. So you have 6 times 2 is equal to 12, 1. 6 times 7 is equal to 42, 43. 10, 0 over there for 5 times 2 is equal to 10, 1. 5 times 7, 35, 36. And then you have a 2, you have a 3, you have a 0, you have a 4, and then times 10 would be a 0 there, so that's 4,320. That's 4,320. That's the total number of permutations related to this. I'm not sure if that's right, but we can test that. I need to pull up my calculator anyway. So you have 9 factorial. You have 9 factorial over. You have 9 factorial over 2 factorial times 3 factorial is equal to 3,240. What? I don't think that's right. 9 factorial is the same thing as, it's the same thing as this thing, and then 2 factorial times 3 factorial is just simply 6 times 2 is equal to 12. So this divided by 12 is equal to 3,240. It seems that I made a mistake there. So that's supposed to be 3,240. I don't know where I made the mistake, but that's the right answer. Okay, so that is that. And then we have a couple of theorems here and a couple of examples that we will go through as well. There's not much here actually to cover. There is a lot of good examples here, or exercises I should say. We will go through a couple of those exercises as well, because they are really necessary to understand the concept. So in the next video we will go through the theorems, and let's see where that takes us. I'll see you in the next video.